SES team is made of individuals with different background and expertise from different parts of the world who are united for the sole purpose of developing the next generation of batteries.
Well, for lithium battery development, we have come a long way. And in the early days, we are doing the material discovery, and many of this work can be done with the coin cell test vehicles. Then we are developing the pouch cell kind of test vehicle for our material study and the engineering study. There's a two type of study. For the material study, we are define a 3-4 layer pouch cell, which is a smaller cell. Then we go to the larger pouch cell, which typically is like a 4 amp hours, 6 amp hours, or even 10 amp hours. After this pouch cell study, we will move toward the real cell design for customer, and which is typically a larger cell, like 20 amp hour, 50 amp hour, or even 100 amp hour cell.
As you already know, so the Sony first commercialized the first lithium-ion battery in the 1991. That's the electrolyte just hasn't been the change until now. But at the SES, in the past 3 years, we developed more than 10 electrolyte generation. So that's very huge achievement.
To make a small cell or a coin cell, that's quite simple and not difficult with any kind of technology. But think about to make the large format cell is totally different.
Working on lithium metal battery is like walking on no man's land. There's not much to follow. You learn from a lot of experiments, and you have to be really result-driven. You have to think out of the box, and you have to do that all fast. It's a race against time.
What I really appreciate at SES is that we always focus on the essential problems and the real results, not the process on papers.
The freedom to imagine and explore solutions without any restriction is the best part of working at SES.
The best part is that we have a team that has come from all over the world, and they work together in creating beautiful battery products.
I'm very confident the lithium metal battery will work. We just need to working hard, working smart, and resolve all the challenges.
Keep up the good work. We've come a long way in these 10 years, and we need to keep going. Just keep the spirits up and keep working hard as all SES employees come work together. I'm proud of working here.
Happy 10th anniversary to SES, and it's great to be part of this team.
Happy 10-year anniversary, SES.
Happy birthday, SES.
Happy 10th anniversary, SES.
In the past 10 years, we built a solid foundation. We don't know what the next 10 years will hold for us, but we know we are at the cusp of a seismic change in the industry. We sincerely appreciate everyone's support and trust. We will continue to innovate, deliver, and evolve. The future will be greater than we can imagine.
Greetings to the extended SES team, and congratulations on your 10th anniversary. On behalf of the entire GM team, thank you for your continued innovation in large-scale electric vehicle batteries. At GM, we envision a future with zero crashes, zero emissions, and zero congestion. Our electric vehicle propulsion platform, we call it Ultium, powers vehicles from small to big, from cars to crossovers to full-size trucks, from Cadillac Lyriq to the GMC Hummer EV. This platform requires us to think big and to deliver solutions that scale. We have to deliver breakthroughs in software and vehicle integration, manufacturing, and most of all, in batteries. Our investment and collaboration with SES will help GM meet our future vision by delivering future battery chemistries into the market at scale. It will help us increase our battery pack energy density and decrease battery pack costs, so more range at lower cost. So thank you and congratulations once again.
Congratulations on this special day for SES team, and a big round of applause for all the employees who made it possible. Everyone here has witnessed what SES has achieved over the last 10 years, and we are very excited to be part of that. Hyundai Motor Company is committed to the carbon neutrality in the next couple of decades, and I have no doubt that SES will be a part of that. I look forward to our journey together. Once again, congratulations.
My first visit to SES was in September 2019. At that time, my project was looking for the advanced battery technology and collaboration possibility of US startups. I expect that Honda's decision to choose SES as a result of our visit was the result of your enthusiasm for the development of lithium metal batteries. I'm confident that if both companies approach the challenge with an open mind and bring our respective strengths to bear, we will achieve our goals. Let's communicate closely on the basis of common language of technology and be the first in the world to bring the lithium metal battery to the automobile market.
The 10-year establishment of SES is a great milestone. The company has gradually become a leading manufacturer in the field of lithium metal battery from a laboratory and is listing on the US stock market. Congratulations to SES and Dr. Hu. Foxconn is a company that pursues excellence, so it's hoped to cooperate with the company with cutting-edge technology. The high-density battery technology owned by SES made Foxconn hope to cooperate with the SES, develop high-efficient electric vehicles to provide consumers with the best driving experience. In the next 10 years, I hope SES will become a battery company comparable to LG Energy Solution. Happy 10th anniversary to SES.
Congratulations, Chitao and SES team. On the 10th anniversary of the company, it is a big day for SES and also for the battery industry. A decade ago, we started our journey humbled, with few people believing in our story. It was your unconditional dedication and hard work that brought us here today. Having served as an investor representative of Tianqi Lithium Corporation and the board director of the SES from 2017 to 2022, I witnessed many ups and downs, experienced many excitements and frustrations. I felt what you felt, but ultimately, it was the company's excellent management and outstanding employees that proved to the people that dreams can be true. You deserve a big round of applause. The industry today is evolving tremendously. The journey in front of us is highly demanding, full of challenging and with lots of requirements. But with your uncompromised dedication and efforts, I have my unswerving confidence that the journey of success will continue for sure over the next decade.
Hello, our SES family. On the behalf of the entire SK Group, I'd like to congratulate on your 10th anniversary. For us, it has been always a pleasure and an honor to be part of the 10-year journey of SES. Although there have been many challenges, SES has always found its way and turned the concerns and worries of the market into expectations. I believe that these dedicated efforts of SES eventually lead to a successful IPO in last February. Above all, the most exciting fact is, for SES, there will be greater growth potential than before. We wish you to further solidify your current technological leadership and successfully complete various development projects for mass production. SK would be more than happy to work with SES if there is an area that SK can contribute.
Happy birthday, SES, on your 10th anniversary. This is Robert Friedland in London. You jumped into my Ivanhoe Capital Acquisition Corporation SPAC. Now you're public on the New York Stock Exchange. All best wishes for the next 10, 20, and 30 years for changing the world with the world's best batteries.
Hi, I'm Anand Kamanavar, the Global Head of Applied Ventures, the corporate venture arm of Applied Materials. Applied Ventures was one of the earliest investors in solid energy. It has been impressive to observe Chi Chow and the entire solid energy team's tenacity and a systematic approach to bringing lithium metal batteries to the world, which has led to top-tier automotive manufacturers worldwide working with solid energy. We look forward to the next 100 years of solid energy transforming the energy sector.
Hi, I'm Jim Cushing, General Manager of Applied Materials Energy Storage Solutions Group. Not only has solid energy been a great investment for Applied Materials, but they've also been a great technology partner too. We've seen solid energy consistently drive battery performance up, culminating in the world's first 100 amp hour lithium metal battery, a truly remarkable feat. Congratulations to Solid Energy, Chi Chow, and the entire team for 10 years of lithium metal innovation.
Hello everyone, my name is Mark Newman. Welcome to our panel, where we have a panel of expert speakers to talk about lithium metal batteries and the future of next generation battery technology. With us today, myself, I'm Mark Newman, I'm hosting the event today. The guests we have, first of all, we have Dr. Young Choi. He's the co-founder and CTO of nPower Group, which is a Japanese-based battery company working on commercializing lithium metal batteries. We also have Dr. Shirley Meng, who's a renowned professor and expert in battery technologies, professor at University of Chicago. We have Maciej Jastrzębski, who's the co-founder and CEO of Lime Metal, which is a company working on commercializing lithium metal anodes as well as lithium metal. And we have Emily Baudouin, who is the founder and CEO of Pure Lithium Corporation, another company working to commercialize lithium metal anodes, as well as other technologies for lithium metal batteries. And finally, Qichao Hu, who is the founder and CEO of SES, which is a lithium metal battery company based in Boston. And apologies to everyone if I've mispronounced any of your names. Apologies. So to get started, I just want to take a step back. It's been a wild ride the past decade or so in the battery and EV industry. We've gone from a small industry, $10 billion or so, to something that's knocking up around $100 billion industry. And I believe it's going to be a $1 trillion industry in the next decade or so. I want to put to you the first question of what milestones have you seen in the industry, particularly battery technology or the industry itself, that's been the most surprising or interesting to you? Shirley, could I start with you?
Sure, thanks, Mark. My personal assessment for the most surprising milestones, the first one, I really have to thank the industry. I think the scale, I mean, this year we passed the 1 terawatt hour production capacities for lithium ion batteries, for the traditional lithium ion batteries. I think in 30 years to reach this milestone, I would have not imagined when I was a graduate student from 2000, early 2000, to see this really tremendous growth of the field. The second thing I would say extremely exciting is all the wonderful invention and discoveries in electrolyte science. Electrolyte oftentimes is considered as the inactive components, only shuttle the ions from one electrode to the other, but actually is the major enabler for new chemistry or advanced batteries. I think, solid state, liquefied gas electrolyte, localized high concentration electrolytes, all of these are extremely exciting for me personally. Because of the electrolyte development, I think that the third and last milestone for me is really to see we are moving beyond intercalation. that the novel anodes like silicon and the lithium metal are really becoming the front runners for the next generation batteries. So yeah, I think these three to me is extremely exciting. I think we'll be very busy in the coming decades.
Great. Yon, can I go to you next?
Sure. I think the biggest surprise to me is like IPO, let's say, for SFC, Dr. Hu and his team, and Solid Power, QuantumScape, these like newcomers or startups got like IPO successfully, IPO on NASDAQ, and got a really good like market evaluation. I think that's the hope that show the hope for next generation battery to play a big role in the like EV markets. Yeah, that's something. Yeah, I really glad to see.
And so, Chiao, over to you as one of the CEOs of one of these companies that has recently gone public.
Yeah, I agree with what Shirley and Yang mentioned. And then, in addition to those, also two things. One is the creation or the realization how important the supply chain is. Supply chain behind these batteries, from mining raw materials, battery materials, to battery manufacturing, and then the batteries are being integrated inside vehicles, and then recycling. This closed loop, and just realizing how important this whole closed loop is from a environmental perspective, from economic perspective, and also from a technical perspective. This part is super exciting. And then also the other is the application of software, AI, blockchain, these new technologies that traditionally people thought batteries were mostly material science, chemistry, but actually now AI, blockchains can actually be used to track data, to predict safety, predict incidents, and then you can actually have new business models. You can monetize all this data around safety. So these are very exciting fields.
Right. Yeah, it's just amazing how things have changed in the last few years, particularly these car companies. Many of them dragging their heels until a couple of years ago. Now they're just jumping in. Most of them, at least, are jumping in completely, 100% all in, because they know that's the future. So now let's talk a bit about some of these new innovations. I think a few of you mentioned about there's been a lot of new innovations here in battery technologies. I'd like to talk about one of these in particular, which is the topic of this panel, which is lithium metal batteries and the lithium metal anodes that are within the lithium metal batteries as really the area to focus on for this next generation battery technology. So the question I'd like to put to a few of you, firstly, I'd like to start with Shirley to get your view, is could you put lithium metal batteries and lithium metal anodes in context for us? Like, what are the key advantages of lithium metal batteries and what are the key challenges? And how does lithium metal batteries, how do they compare with other technologies that we all hear about, such as silicon dominant anodes and solid state, which is a kind of a bit of a buzz term that we hear out there a lot?
Certainly, Mark. Let me see how I can do this without the slides. It's my occupation hazard that I always have to use slide. But lithium is on the periodic table number 3, so lightest metal. If you live on the planet Earth, I think lithium metal is the ultimate choice for the metal anode. I think one have to really realize it is almost half a century of work went into utilizing lithium as the metal. What made things so different today compared to 50 years ago is really we had those breakthroughs in electrolyte science. Now we know how to stabilize lithium metal in the electrolyte. And solid state is just one of those options. Whether you use solid state or not is not the key. The key here, electrolyte is the inactive component. lithium metal anode intrinsically will lead to higher volumetric and gravimetric energy density, comparing to the counterpart of graphite, which is intercalation anode, or silicon anode. So let's talk a little bit about silicon. I think the challenge with silicon is so far we have seen in liquid electrolytes compatibility studies with lithium metal that is 99.9% compatible, really, really compatible, highly compatible electrolyte with lithium metal. We are having a lot of challenges finding the compatible electrolyte with a high silicon loading, more than 78% of silicon loadings to be extremely stable in liquid electrolytes. So I think if I have to say that, thinking about the longevity of cycle life, this electrolyte compatibility is the key. So that's why I do think in the anode race between lithium and the silicon, I have to give kudos to the people who work on the lithium metals, because they really, really worked out how to find a good electrolyte for the lithium metal. The other things people probably didn't talk too much, but I know that SES, I did the due diligence report for SES, the high discharge, high power capability of the lithium metal was something we did not see in the silicon metal anode or even graphite anode. I think that there are special performance metric improvement coming from the lithium metal anode beyond just a energy density number. So I think there are those facts that we all have to take into considerations, and that's the reason why all of us are super excited about the lithium metal batteries.
Great. And I'd like to hand it over to Qichao. Would you like to comment on this topic?
Yes. So I think the two key areas, so Shirley mentioned about the electrolyte for sure. That is by far probably the most important aspect. And then another is the supply of this lithium anode. Actually, very few companies in the world today can produce thin lithium anode. People make thick lithium foil for primary batteries, and then now they make thin lithium foil for silicon pre-lithiation, and then now use as anode for lithium metal cells. So this part, a lot of supply chain challenges, engineering challenges to produce this material at scale and also low cost. Another is more on the safety management side. So most batteries actually it's really hard to make a battery 100% safe. And when you get to very high energy density, like you have with lithium metal, it's really hard to make this battery just fundamentally inherently safe. But then you have to make the vehicle 100% safe. So for very high energy density cells like lithium metal, you can use a software to very closely monitor manufacturing quality control. Instead of leaving it to probability, to yield, like what the industry currently does. For example, even if you have parts per 10 million or parts per 100 million defects, but when you have hundreds of gigawatt hours, parts per 100 million, that's still thousands of cells catching on fire. So the traditional way of manufacturing quality control doesn't work. And then you really have to apply a new type of quality control. And then once the batteries are implemented on vehicles, you also have to constantly monitor the data so that you can predict any incidents, any unexpected incidents before they happen.
My question for a follow-up question to all of you, though, is do we really need solid-state electrolytes to enable lithium metal batteries, or are the liquid based electrolytes that Qichao and others are working on, is that good enough? So yeah, I mean, Young, you also maybe to start with you, because you're also working on liquid.
Yeah, actually,
you have both technologies. So maybe you can answer.
Yeah, we're working on those the electrolyte, the liquid-based electrolyte, and also solid. We have very close collaboration with Professor Arnold, who is the one invented this called LGPS. That's a sulfide-based solid state electrolyte gives the highest ionic conductivity. So we're working out both sides. Hopefully, that's another perspective from Japan. They moved from lithium metal, liquid base, to lithium ion. And they want to see a big world to enable the lithium metal. It's not really just to go back to the very first lithium metal secondary battery. The disadvantage for solid state is it's really hard to build the interface like the solid side interface and doing the cycling and to still keep like the very nice contact for the solid interface. And also we see the difference like liquid versus solid. Actually, solid state probably give you a safer performance, but not really higher energy density. Actually, by using solid electrolyte, actually you sacrifice a little bit, sacrifice some energy density compared to the liquid-based one, because you have to add more weight, more mass of the solid state electrolyte.
So it's actually worse.
Yeah,
it's actually
still compare and see how mature so it's not really lithium metal versus solid state. Could be an enabler to each other, but we're still working on that. So liquid so far gives higher energy. We can achieve something like about 500 watt-hour per kilogram, but it's really hard to do with solid state chemistry.
I think Emily, you wanted to come in here?
Yes, well, I just wanted to point out that in our view at Pure Lithium, the metric should be flammable versus non-flammable. The battery needs to be safe. Whether it's a liquid or whether it's a solid is really immaterial. Right now, there are two camps, and you have entire battery conferences that really believe that solid state is synonymous with lithium metal being utilized, and that's just not true by any stretch. There are definitely pros and cons to both, but the metric should be safe, flammable versus non-flammable, and you can accomplish that with a liquid.
Yeah. I think there's a lot of confusion. You put it perfectly. There's a lot of confusion out there mixing up solid state with lithium metal, and people don't really realize that you can do lithium metal with or without solid state. It doesn't have to be solid state. Solid state is just one way to enable lithium metal batteries. So next question I wanted to go on to was talk a bit more specifically on the anodes, the anodes themselves. So I'd like to understand the different ways that you can make these lithium metal anodes. What are you? So this is really for Maciej and Emily, the two lithium metal anode companies out there, and I think Qichao also has a view here as well. How do you make these? What are you doing currently, and what are the challenges associated with this? Qichao, did you want to kick off on this?
Yeah, sure. So I think the production of this thin lithium foil, production and recycling of the thin lithium anode is super important for next-gen lithium metal as well as silicon batteries, because you do need thin lithium foil for both. And today, just around the world, there are no real companies producing this. There are some small companies producing this at small scale, super expensive. It's just a non-starter. And there are larger companies trying different techniques, evaporation, extrusion, printing, and Maciej and Emily also have a quite novel process for making this, but really to take this technology, next gen lithium metal and also high content silicon to commercial, this has to be low cost. Material, it's just elemental lithium, right? So it doesn't matter how you make it, it has to be low cost, and hopefully Pure Lithium and Light Metal can solve this problem for the industry.
So thanks for that. And then Maciej, I want to give you a chance to talk about what you're doing here in the production of lithium metal anodes.
Sure. Yeah. So as Qichao mentioned, the
the existing process is really foil production. So the problem with foil is relatively well known. You can probably characterize it as the foils are too thick, too narrow, and too costly. And that just has to do with you're working at the limit of what that process can do. And so you tend to have a hard time producing the material that's customized to next generation batteries, where you really want to minimize the amount of material to whatever it is that you need for the battery. For different technologies, you may want a little bit more or a little bit less on the anode, but generally speaking, it's less than you can deliver with a foil. So our approach is to deposit material onto a substrate, typically the current collector. We use a physical vapor deposition type approach. The nice thing about that is, physical vapor deposition as a concept has been around for quite a long time. Most of the cheapest metallic-looking materials you've seen, anything that's plastic and shiny, has probably gone through a physical vapor deposition process, and usually those are kind of throwaway items, like packaging materials and so forth. So what we really do, our goal is exactly what Qichao alluded to. It doesn't matter how you make it; it's got to be inexpensive. So the way you do that is you have a high throughput process that minimizes the amount of lithium that's deposited to whatever is the requirement of the battery, and of course, the quality has to be there. So our process allows wide format deposition. Eventually, once we're at commercial scale, it'll be at similar widths to what the rest of the battery components come in, so that you can do everything in parallel.
And then, Emily, you're also in this business of making lithium metal anodes. So, could you talk about what you're doing and how it differs?
Absolutely. Absolutely. So my co-founder and our chief scientific officer is Professor Donald Sadoway of MIT. And in 1996, he wrote a paper titled "Towards New Ways Toward Lithium Production," basically calling out and saying that if we didn't fix the way lithium metal is made, forget about next generation lithium metal batteries. And he had a really good point. Besides the fact that it's exorbitantly expensive and environmentally damaging, the end product is just not sufficient for a rechargeable battery. So what we have invented at Pure Lithium is really Don Sadoway's work, a very novel electrodeposition method. And electrodeposition, for people who don't know, it's a very well-known method to produce in situ metal coatings by the action of an electric current on a conductive material that is immersed in a solution containing the salt of the metal to be deposited. So take a bath, right? A lithium sulfate aqueous bath. Take a substrate, it's in that bath, and we have tricks that we do with that substrate. We've invented a novel polymer coating that acts quite like a leveling agent. And thus far, we've made films that are 80 by 110 millimeters, and that's not large enough for the large format that Qichao is going to need, but we're working on it. We're only a year and a half old. And we coat our copper with this polymer. And then we have this optionality of using different salts, which is incredibly important to me. If you look at the price of lithium carbonate, the spot price went up to $50,000 a metric ton. Now, yes, that's only about 20% of the actual market. The rest of it is under very long-term contracts, but that's not feasible. But if you want the price to go down, the first thing that you have to do is you have to buy the cheapest salt possible. And that's what comes out of the ground the earliest, and that's called lithium sulfate. So we take lithium sulfate or a carbonate, any salt, but sulfate's our preference, mainly because of the cost. And we electrodeposit it through this polymer membrane onto the copper. And we control the thickness of the film by the amount of time the deposition is running in the current density.
Great. I'd like to follow up on commercialization now, and it's really to all of you that are in this field. All this technology sounds great, but when are we going to see it in a car? That's, I think, what everyone wants to know. I guess, Emily, we could start with you since you were just on, and I'll go around.
Well, I mean, hopefully Qichao is going to lead the way and have the first product in a market. I do not anticipate being able to supply Qichao material that he can use in his battery for 2 years. If we can do it faster, we're absolutely going to try. But realistically, this is a new technology and all of these things take a while to commercialize. So I'm giving it at least 2 years. And hopefully by the time he's in the vehicle, we'll be right there to back him up.
And Xixiao, since she referred to you, so maybe to you next.
Yes. So now we are in A sample, and when we first started working on A sample last year, for example, this battery behind me, back then, no company in the world could make thin lithium foil that wide. It's about 600 millimeters wide, and you have no idea what we had to do to make anodes for this A sample, and that was very challenging. And so that's A sample, and then so A sample, basically, this cell will still have to meet all the technical specs, the high temperature, low temperature performance, shelf life, safety, cycle life, energy density, basically hundreds and even thousands of test items. And then once you get a B sample, then this will have to be integrated into modules, 12, 20, 30 cells per module. And then the modules will have to meet all the specifications. And also in B sample, then all the supply chain, all the materials, the cathode, anode, electrolyte separator, pouch tabs, all the materials, the OEMs will have to check, is there a reliable source, low cost, high volume source for this material? If that doesn't exist, even if the cell works beautifully, that project will get terminated because it's just not feasible. And then once you get a C sample, then the modules will get tested in actual vehicles. And then you have test vehicles, and then you have real vehicles, and then different drivers in different countries, in different weather environments, different pressure, temperature environments. Then you have to collect all the data, and then you have to constantly basically monitor the battery health.
And then Maciej, over to you to talk about what you're doing for commercialization.
Sure. So, we've several months ago now commissioned our pilot anode production facility in Rochester, New York. So this is sort of like an intermediate step between development and commercial production. So that facility is able to deliver a product that's on a 200 millimeter wide substrate. That's wider than any foil that you can get. The next step. So we're using that basically to sample material. We're sending material to companies to test the anode products. We're able to produce anywhere from between about 3 microns up to 20 microns thick deposits on those anodes, so we can customize based on what people are really need with their battery technology. And then next year, we're building what we call the commercial scale demonstration plant. This will be a full-size industrial scale production facility, one of what would eventually be a number of lines to give you gigawatt scale production capacity. But basically, that will be a full format, 600 millimeter wide format anode produced at scale, hundreds of thousands to million plus liters of that material per year. Our entire commercialization strategy is really centered around getting to the point where we have that capacity where we can support those activities.
Great, exciting stuff. Young, I'd like to give you the chance to comment on your commercialization.
Okay.
If you could be brief, because we're running out of time.
Sure. I was from the traditional auto industry. I worked for the company part of Toyota Group for a long time. I believe the EV is the largest market for next generation batteries, including lithium metal battery. But I think there's some earlier adopters, new market, let's say some niche market. It's more sensitive to energy density and less sensitive to the cost. And we are closely working together with SoftBank on the HAPS, high altitude platform station. That's a kind of like aircraft flying really high. And also, we try to supply our battery samples to drone companies. So I think we want to get to the market earlier than it can be used in the EV.
Great, that's great. That's good to hear. So just as a wrap up, we're about out of time. So just wanted to go around and ask you all to mention one thing that you think people are missing in this battery industry and battery technology. What is something that you think people are missing that you wanted to raise to us today? Shirley, can I go to you first?
Yeah, as a professor, I would say that the time for workforce development is coming, and we have been missing these key components for electrochemistry and electrochemical engineering for quite a few years. So I just take this opportunity to pledge that we really have to take actions, because once all the supply chain issue is resolved, the manufacturing is ready, we will need the brains to make things happen.
Great, fantastic. Emily.
Thank you. I really believe that we need big paradigm shifts. Battery manufacturers to date are so incrementally motivated. You think about conversations with people and they talk about the industry like renovating a house. You want to do the kitchen. But I think to make great change, you have to tear the kitchen down sometimes.
Thanks for that. And Majay, over to you.
Yeah, I think one of the things that we're definitely starting to become a little bit ossified in the at least in the lithium-ion battery industry, in the sense that we've gotten used to thinking about the lithium-ion battery industry, and we have all these projections of how many gigafactories, et cetera, are going to be built. And I think what people don't realize is that as soon as a few of these next generation battery technologies, perhaps even one, finds application in a mainstream electric vehicle, with all its advantages, it's going to be so hard to continue to justify building any of the old technology. So I think people underestimate how quickly that change is going to happen. I think it'll be almost within the span of months or a year or two at most, where lithium-ion batteries will just start to be referred to as legacy battery technologies, and next generation battery technologies are just going to be called batteries.
That is very interesting. Young, over to you. Do you have any comments here?
From engineering perspective, so the battery we make these days have three different shapes: cylindrical, prismatic, and pouch cell. But for all the startups making lithium metal battery IC, all make pouch cells. So I think the cylindrical shape is missing, and actually we're working on that. There's one reason cylindrical could be more practical, because the pressure issue. Now we have to apply the pressure onto the pouch cell, but for a cylindrical, it could be stay along and without any actual pressure.
And then Chichao, over to you to wrap up.
Yeah, I think we need a mind-to-man AI that can predict 100% of all the safety incidents. So it's an AI that can collect all the data from the mines, the cost, carbon footprint, location, battery manufacturing, all the quality control, very, very detailed. Not like the current quality control at the yield, at the aggregate level, but very, very detailed. And then once the batteries are incorporated in vehicles, the user behavior, and then end-of-life recycling, basically this closed loop software, this closed loop AI that collects all the data, and then you can predict 100% of incidents, and then this will allow you to actually have new business models that are quite exciting. You're on mute, Mike.
Great. I'd like to wrap up this panel. We're over time. I'd like to thank all the guests for joining us today. If you have any questions, please feel free to email me at insights@electricrevolution.info. I'll try my best to get back to you. And thanks very much to everyone joining today.
Thank you.
Thank you.
Thank you, Mark. Thanks.